All right, welcome to this little talk about a topic that I hold dear to my heart, algebra and particularly quadratic equations. Now, why am I excited about this? Because I think I'm going to share with you something that will absolutely blow your mind, something that as a math person, I couldn't wait to start sharing some more math stuff now that I get a little chance to relax. So I have this method that I want to throw out, and I really want my math teacher and math educators out there to have a good look at this method and say to me, Miguel, this doesn't work. But really, I want students who have had challenges with quadratic equation, and especially moving into math methodology, like you looking at this and saying, could this get people to move past some of the barriers they face in quadratic equations? So I'm going to take you through a quick thinking on this, and please bear with me, but I guarantee at the end of this you're going to be like, wow, why wasn't I taught this method in school? And then your next thing will be, when I teach quadratics next time, this is how I'll do it. So I need to take you through it, and I want you to challenge this when you see it, okay? So I'm putting a standard quadratic equation here. X squared minus 10x plus 21 equals 0. And right away, if you're good at this, you'll go, this can be factorized, it's straightforward. But I just want to take you through a process for the first 2 or 3 slides, just to make sure that you understand how this new method will shift all of this and change your whole perception of what your teachers were telling you. Yeah, and even me, I might not have told my students about this either. So here's the thing. We normally would look at this and say, okay, the normal procedure is that we're looking to find 2 numbers that we can put in the brackets just like this. 2 numbers we can put in brackets like this to solve this equation, okay? To solve it, to find the factors, and then we know what P and Q are. We're looking for the roots of the quadratic. So nothing's changed here, but I want to keep that conception going because simply this is what we're going to be searching for in this situation. So normally the teacher would say to you, you need to find 2 numbers where the product is minus 10, 10, and then if you add them, you get 21, yeah? So what we're going to do now is I'm going to shift this a little bit because standard we'd spend a lot of time trying to find the numbers that work. For 21, I would go 3 times 7 or negative 3 times negative 7. And in the end, we would end up with the numbers that works. In the end, we get negative 3, negative 7. And then we know what those numbers would be, 7 and 3, to go into this formula. So we would figure this out. And many students found that intuitive. In fact, found that a little bit unintuitive, sorry. A number of students that I worked with, the moment you gave them the first part, they always go for the sum. The sum is 10. And they try to work the sum, and you'd have to reorient them to what was taught in school. Now, this new method, and it's not new, because this was invented by the Babylonians over 5,000 years ago. And no one was using this in schools. Why? They kept the natural, intuitive way of thinking about this and solved every quadratic. So if we wanted 3 and 7, so let's go and have a look at this again, and we're going to take the Babylonian method for this, and I want you to really follow me. The first time will be a little bit slow, but the next ones you're going to see how quickly this is a powerful tool. So rather than focus on the product, we're going to focus on the sum, and we're going to ask the questions. What 2 numbers add to get 10? Just bear with me as I work through. You might be thinking minus 10, but we're going to go with 10. We go with minus b, okay? And here's a thinking. We need to think of 2 numbers that add to get 10. Now, everyone could think, we could think 5 and 8, 2 and 5 and 2, 5 and 5, 8 and 2, 6 and 4, 10 and 1, 11 and minus 1. So there are a number of, a large infinite set of numbers that would do this. So the whole point here is that the reason why teachers would say to students, don't do that road, because there are so many combinations of 2 numbers that make a sum, a particular sum, that teachers would say it's better to focus on the product side of it, which normally is limited, and depending on the number, it might not be too much. As the numbers get bigger though, your students who aren't competent with times table begin to panic. So let's go back to 10 and we think about, could we come up with a general structure of 2 numbers that those 2 numbers will always add up to 10. It doesn't matter what. And so I want to share with you a kind of average approach. So if I take that 10 and half it, divide it by 2. If I take the same number from 1/2 of 10 and add it to the other half of 10, those 2 numbers will always add up to 10. Let's try it. So if I say m in this case is 2, 5 take away 2 is 3. Okay? So 5 take 2 will become 3 here, but 5 plus 2 is 7. 7 plus 3 is 10. It doesn't matter what m is, it will always add up to 10 simply by splitting 10 in 2 and then taking away the same number from half of 10 and adding a same number half of 10. Algebraically, it works as well, simply because if we add these together, minus m plus m is 0. So this is a conception you need to keep, because this is like the key idea in what we are going to do. So we know that our solution to our problem, remember, we're just looking for two numbers. If we add them, we get 10, but when we multiply them, we get 21. This is how we will approach this problem. If we add them, we get 10, we multiply them, we get 21. All right? So this is a conception that we're going to approach this problem, and we don't care. We don't care if m is negative or positive. We're simply going to find that number that if you take it away from 5 and add it to 5, you will get 10. And we don't know which specific one works for 21. So keep the idea. I want you to keep the idea, because it's a very powerful concept for finding any two numbers that are the same distances apart. Just add it, just get halfway, then add on any number, and it will always work. So let's move on. So let's take our problem and begin to solve this problem now. This is a step-by-step approach to using this method to solve it. And you'll see how I end up back in the same place, and you're going to be like, whoa, that's interesting. Now watch this. So if this is one of the number and this is the other number, that if you add them you get 10, this number, if we multiply them, we should get 21. So I've not changed the way how we approach a factory problem. All I've done is approach it from a different direction. I don't know what my m is, but I know that together this should give me 21. So we're multiplying the two numbers that if we add them we get 10, but if we multiply them we get 21. So I'm going to carry on with my expansion. Now obviously this is the difference of two squares. So that just gives me 25 minus m squared. Difference of 2 squared, that's a simple concept in math, but if you want to go over it again, 5 times 5 is 25, minus m times m is minus m squared, and then you're going to have the middle term disappearing. It's a difference of 2 squared. So we're carrying on step by step here. Next we have m squared is 4, because if I rearrange, the 21 goes here, the m goes here, m squared becomes 4. We can do that straightforward in math. That's an easy jump for what's happening here. M is 2. So now I found m to be 2. Now for me to get to my final solution, I simply need to put that 2, this 2 that's found here, back in to get my two numbers. 5 minus 2, that gives me 3, and 5 plus 2 is 7. Done. That's a quadratic solved. Now you might think, oh, but I could have gotten that one already by factoring. But notice just my steps. You're going to see now how powerful this method is, because I'm going to graduate it a little bit, moving it up and down through different types of problems to show you that the steps are the same. The mathematics is the same. The solution, though, doesn't matter what kind of answer, whether it's a decimal, a fraction, or complex numbers. It's the same thing, simply by keeping a very basic concept. We start with the sum and not the product. Because the product, normally when I say to students, find numbers that multiply to get 36, they spin around, they try 4, then they have to try the negatives. And if their number concepts aren't strong, they spend a lot of time trying to find these numbers, and they can't add easily, they can't make the connections easily. Bright students can. This is a way in which we bring everyone together. Let's look at another one. X squared minus 6s minus 27. Good students might quickly see this. The majority of students will spend a little time trying to find which combination works. So we carry on. Notice that I begin by saying get 6. We're not worried about the minus sign here. You'll see how it fits into other type of problem. We're focusing on the sum, not the product. So we're not interested in how we get the 27. How could we get the 6? Now remember the method. We go for half of 6, which is 3, and then we plus and minus an unknown number. So we should get 3 minus m and 3 plus m. These are the two numbers. Whatever m is, we don't know. We're going to find out later. These are the two numbers that will solve this problem. 3 minus m, 3 plus m. And we know that if we multiply those two numbers together, we should get minus 27. With me? Great. Now, expanding Difference of 2 squares, so this will become 9 minus m squared. Nothing great there, and this remains as minus 27. I'm just trying to find m. By rearranging this, you'll see that m is 36. M squared is 36, which means m is 6. Now you notice that I don't even bother trying to do plus or minus 6, because I've already set this here. Because it doesn't matter if I go with minus 6 or plus 6, it still works. So m is 6, I get 3 minus m, which is minus 3, and then 6 plus 3, which gives us 9. If I went with minus 6, I'll get 3 minus minus 6, which is 9, and then 3 minus 6, which is minus 3. So it doesn't really matter whether we just go get the 1 square root of m. It doesn't matter. We don't want to confuse the issue too much. Solution, 3 minus 6, 3 plus 6. Done. Sure you're wondering now, this looks like it can work. This is a bit fast, and we don't have to worry too much about finding those numbers that people used to spend time going, is it 6 and 3, minus 6, minus 3? And I remember when I was in university, I realized that a lot of people could factorize just by inspection. They'd make the brackets and the try numbers and minus. And after a while, I realized that was far more efficient than my grouping method. But even then, I didn't realize that there was a faster way. If you're very good at math, by now you start seeing the patterns that you can do this all in your head. Don't have to worry too much about it. Let's try another one. Bigger number, and that's when it starts to get tricky. I say, okay, solve this one, guys. Minus 165. They're looking at that in their mind going, oh God, how am I going to get 4? They're thinking, look at the one. All right, let's start with 4. Look at numbers. So keep the method in mind. Follow me. So your first step should be this. Hope you're with me. 2 minus m, 2 plus m. These are the numbers. We half the 4 in 2, and we decorate m, and we add m. It doesn't matter what m is. If m is 100, it will still add up to 4. Let's try it. 2 minus 100, minus 98. 2 plus 100, 102. What's minus 98 plus 102? 4. So it doesn't matter what m is. This concept makes sure that the two numbers will always add to 4. We only need to find out what m is. Now, to keep it going, we need to know the m, the specific m, that when it's multiplied together, it gives us 1 minus 165. With me? Stay with me. Carrying on. We expand, methodology is the same, because that's difference of 2 square again. So we end up with the same thing here, and by rearranging, we get m squared to be 169. Now, some people may take a little bit more time to get from here to here, but it's not even in question, the mathematics to get there. And now we get m is 13. Finished. Amazing, isn't it? So with the 2 minus 13, 2 plus 13, minus 11 and 15. That works. You could have a child spending hours trying numbers and might even get the order wrong. So just think about that for now. I just don't even need to, I could now factorize if I wanted, because if I know that x is minus 11, I can go x plus 11, x minus 15 to factorize. If I really wanted to, I could use that to do factorization in reverse. But the point here is done. So you might say, hey Miguel, why are you doing problems that I can factorize? What if does this work for problems that can't be factorized? Let's try. So we have x squared plus 10x plus 29. I'm going to be really, really critical here. I'm going to try it. Let's see what happens. Now notice here, I have a positive 10. So I've put minus 10 here. So my number that I'm trying to find is minus 10. So one quick thing to realize, I always go for the negative of it. Okay? So that leaves me with minus 5 minus m and minus 5 plus m. Trust me, it works. We don't need to worry about it. When we add minus 5 to minus 5, we end up with minus 10, and minus m plus m is 0. So it doesn't matter what m is. As long as it's the same number, it will work. So I want you to stay with me. Stay with me. So, methodology, the same. Same. These two numbers, whatever they are, when they multiply, must give us 29. That's a specific number we're looking for. Expanding, coming down, we get minus 4. Ooh! Can we find the square root of a negative number? Of course, if you bring in complex numbers, which we will, because I want to show you that this method has no limits. No limits whatsoever. So, if we find the square root, you get 2i. Now, if you don't know complex number, don't panic. It's literally a way to deal with negative square numbers that are when you're trying to find the square root of negative numbers. And the methodology is that you multiply by minus 1. The square root of minus 1 is I. Square root of 4 is 2, so you get 2i. Don't have to worry about it. You don't have to learn it. You just have to understand that the methodology is the same. And then the final answer would just be minus 5 plus 2i and minus 5 minus 2i. Look at that. 2 lines. Boom. Done. Sorted. Not finished. Let's try this one. Here's another one. X squared plus 8x plus 6 equals 0. Let's go. So you know by now you're looking for a number that adds up to minus 8. Okay? We're not caring about this, not yet. We're going in reverse. So half of minus 8 is minus 4 plus and minus m. Got it? That step is easy now. Everyone should get it. And then we know this step as well. We know that minus 4 minus m minus 4 plus m must add up to 6. We're looking for a specific m that does this. Difference of 2 squared, meaning expanding properly. We end up with this. And then we end up with m squared equals 16 minus 6. M squared is 10. Okay? Root of 10. Yeah? Square root of 10. Done. Problem is done. Because I literally just need to put that in. Minus 4 plus root 10, minus 4 minus root 10. Now, I want you to pause for a bit. I want you to think deeply and say to yourself, could you have solved this problem in your head? Just like that. Think about it. If I know what's going to happen, I know I need minus 4, right? I know I'm going to square minus 4 and I'll have to take this number from that. Simple. So 16 take away 6 is going to give me square root of 10. I'm done. I just need to find that last number. You just half the first number, half the number, first a minus sign, sorry, half it, square it, take away c. Kalas. I could do any problem like that. Any problem like that. And then just add it back onto minus b or minus b. So let's try another one. Now, someone said to me, hey, you want to do in ones that have this middle number to be an even number. So it's easy. Let's try it, but let b equals 3. It's minus 3. So let's see what happens. Let's go. We go with 3. Same problem. But now we divide by 2. We get 1.5. I'm going to do this in 2 ways. Just to show you the flexibility and whatever you like. Now the standard math person might not want to do this, but I want to keep the numbers simple first so the ideas flow. Then after that I'll show you with fractions in it. So let's go. Minus 1.5 minus m minus 1.5 plus m equals 1. With me? Great. Let's go now. 2.25 minus m squared equals 1. Because when you square 1 minus 1.5, that's what you get. Sorted out 1.25 and it's done. I'm sure you know it's done by now. It's 5 lines, man. 1, 2, 3, 4, 5. And then the answer is 6. 1.5 plus or minus square root of 1.25. Easy peasy. Watch me. Not finished. I'm going to do it now with fractions because sometimes people might think, hey, decimals, not the way to do math. I don't really do decimals much in math. I'm a fractions guy. Fractions allow me to multiply more tricky numbers than if I had it in decimal form. So let's go. Same problem. But now I'm throwing in fractions. Now to find half of any number in math is just divide by 2. Key concept to understand. If I put it over 2, it's done. What's half of 4? 4 over 2. Alas, okay, it's 2 as well, I know. But this is the point. So let's go now. Now, 3 over 2 minus m, 3 over 2 plus m. Nothing changes. Equals 1. Expanded, 9 over 4. It's going to be complete difference of 2 square again. Then we do that. M squared is 5 over 4 because 9 over 4 take away 4 over 4 is 5 over 4. Done. Problem is finished because I square root this. Root 5 over 2. Normally when you square root, you can just square root each part of the fraction. So square root of 5 over 2. You could have written square root over 5 over 4. But you're math people, right? Done. Plus or minus. Halas. That's easy, isn't it? Halas, sorry. I say halas in where I am in Arabic language. Halas means done. Done, 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 done. Halas, 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 halas. Okay. That's fast. And that was not an easy one. Someone says, hey, but what if there's a number in front of x squared? I notice that you're just doing easy ones without any. So now I'm building this up to make the case that this works for any problem. It doesn't. So far I've done one, we've done somewhere. We have no number in front of x squared. It factorizes as well, but we'll just show you that there's a way to deal with it, even if it's easy or hard. Then I gave you some where we had complex numbers coming in or imaginary numbers. We also, I also showed you one that had square root in the answer. So it's not a normal, it's just a standard one that in your time would be using the formula. And I've just shown that the formula holds nothing compared to this. All right. But then you might not be happy. You're thinking, hey, Miguel, come on. You can't trick me. How do you deal with this one where you have a number in front of x squared? Notice you have avoided. The trick is simple, man. Just divide by 2. Do I need to do any more after I've done that? Divide by 2. If I divide by 2, I get x squared minus 4x minus 8. How different is that from where you were? Yeah? How different is that from where you were? Yeah? It's like if you're living, if you know how to get from, if this is the way that you're comfortable with, yeah? You know this. If you, for example, let's say you're flying from London to Beijing, yeah? But you've never really traveled from London directly to Beijing. You know how to get from Dubai to Beijing all the time. And you're now stuck in London. Yeah? And you want to get to Beijing, like, how do I do that? What you can do is first, fly to Dubai. So this is your division. Get to somewhere you're comfortable and then move on. So we divide by 2 to get rid of a. And we can always do this. Whatever number that's in front of x squared, we get there. And that method, I remember going through a book called Certificate Mathematics. It was so unintuitive. We had to use completing the square, and I'm like, how does someone know that you should use completing the square? So for me as a math person, the logic was never there, but I could remember it. But no one who was not a math person could have even thought about doing that. So my methodology was to follow it. I learned it and I was great. But here's the thing, guys. I'm going to show you a way to derive the quadratic formula that I guarantee you haven't seen yet. And if you have seen it, it's because you're a Babylonian. Got it? So here we go. So the first thing, the standard quadratic equation would have x squared plus bx plus c equals 0. Now this approach always requires you to divide by a. So I divide by a, and this is what you get. X squared plus b over an a plus c over a. Sorted? Good. Hope you're fine with that. So now we're going to work through this. First stage, just like normal, I need to find half of b over a. We need to put a minus b, over a, and then divide it by 2. To divide by 2 in math, just put 2 in the denominator. So this is half of b over 2. Now this is for the higher level stuff now. So if you're just trying to understand math, you're okay. Done. This is what my teacher friends were thinking, Miguel, I know it doesn't work for the formula. And I'm like, I'll show you. So keep with me, my teacher friends and my A-level math students who want to move on and learn how to get to this point. Stay with me. So, minus b over 2a minus m and minus b over 2a plus m. This will always add up to minus b over 2a as long as we keep m the same. We know this because we have tried it with numbers. So I'm not debating this, I'm not proving this. I'm just going with the fact that you know that this will work. This m stands out. It works all the time. This is math, basic arithmetic. So, first step, we need to find two numbers. When we multiply them, and we only need to know m, the m that works, and when we multiply them, we get c over a. Nothing's changed. Problem is the same. Problem is the same. Nothing's changed. Nothing's changed. Nothing's changed. Off you go. So, if we use the difference of two squares to go reverse expansion, we end up with b squared over 4a squared. Good? Minus m squared equals c over a. Nothing's changed. Follow me, guys. Stay with me. If we're going to solve this, we need to move this part to here and that to here to get them into positive. So m squared is going to be b squared over 4a squared minus ca. I'm kind of going slowly because I'm not sure if I made an error when I started to type. But I think I'm okay so far. Yeah? So, b squared over 4a squared minus c over a. Carry on. I'm just going to make them having the same denominator here. So I just need to multiply both of the top and bottom by 4a. That's okay. A is not 0. So we know it's okay. Yeah? We're only multiplying by 4a because we know a is not 0. Why do I know that a cannot be 0? Because obviously this doesn't work if a is 0. But it would not be quadratic if a is 0. If a was 0, it's not quadratic. It's a linear equation. So we don't need to worry about multiplying by 4a and all the possible things that would happen if a was 0. So we know that a is not 0. So this is safe mathematics. So now we have the same denominator. We can combine into one fraction. You see I'm getting there, right? Looks like I'm beginning to get there. B squared minus 4ac over 4a squared. So I'm just going to go, I'm going to find m. And here my plus and minus comes in because I can get two different answers here. I don't really need it because we talk about it. We're going to stick them in. But I'm taking you to the quadratic formula. And I want to take you there step by step. I don't want to leave you halfway. So we can always find the square root of the denominator. That's going to be 2a. Yep, makes sense? Stay with me. Anyone can learn this. Anyone can learn this. You could teach this to anyone. This is mind-blowing. And then now, I've found m, so I'm going to go back now to here, and I'm going to replace my m in this, but I don't need to do it twice simply because now we have the plus minus. So I'm just going to put that in, minus b over 2a. We know that it's going to be plus minus that number. We're going to add it onto it, minus it from it. Can you see it's happening? My final step, because the denominators are the same, we can join them together in one fraction. Does that look like the quadratic formula? It's all good, isn't it? All good. Minus b plus or minus b squared minus 4ac over 2a. Amazing. So I'm just saying that go and try it. Let me know. Because maybe you think this method doesn't work for some numbers. I think it works for anything, and I think it's a far more compact, more intuitive method than the ones that teachers have been teaching students for years. And this would solve a big problem. One method that works for all. I wouldn't put factorizing on the sideline because of its benefits for later mathematics, but definitely we don't need a formula. That's my point. The formula is not needed at all, at all. The formula could just be thrown in the bin, and then this, most of it as well, allows you to solve these problems mentally as well. Very easily you could solve quadratics by just thinking of the numbers and the relationships. Now, as I said before, this is not new. My big question, this was discovered by the Babylonians 4,000, 5,000 years ago. So why? Why were we taught another method that was far more challenging and far less intuitive? That's my question. I'd certainly like to talk about it, and I hope people want to talk about that. But try it, and then let me know. Please let me know how it has worked for you, because I'm really, really keen to know how this has worked and whether this is the first time you've heard about this method. Signing out, this is the doctor speaking, and I'm leaving it to you to figure this out. Thank you very much.